Atomic batteries offer a new approach to carbon-free energy. MIT nuclear battery concept. This removed delivering of the MIT atomic battery idea shows significant segments, for example, the instrumentation and control module, the reactor, and the force module. Credit. Courtesy of the analysts. Jacopo Buongiorno and others say production line fabricated microreactors shipped to utilization destinations could be a protected, proficient choice for decarbonizing power frameworks. We might be near the precarious edge of another worldview for atomic force. A gathering of atomic experts recommended as of late in The Bridge, the diary of the National Academy of Engineering. Much as huge, costly, and brought together PCs offered route to the generally appropriated PCs of today. Another age of moderately small and reasonable manufacturing plant-assembled reactors, intended for self-ruling attachment and play activity like connecting a larger-than-average battery, is not too far off, they say. These proposed frameworks could give warmth to modern cycles or power for an army installation or an area, run unattended for 5 to 10 years, and afterward be shipped back to the industrial facility for repair. The creators, Jacopo Buongiorno, MIT's TEPCO Professor of Nuclear Science and Engineering, Robert Frieda, an organizer of Gen H, Stephen Almayer of the Idaho National Laboratory, and Kevin Chilton, resigned administrator of the U.S. Vital Command, have named these little force plants atomic batteries. Because of their straightforwardness of activity, they could assume a critical part in decarbonizing the world's power frameworks to deflect disastrous environmental change, the specialists say. MIT News requested that Buongiorno depict his gathering's proposition. Q. The possibility of more modest, particular atomic reactors has been examined for quite a long while. What makes this proposition for atomic batteries unique? The units we depict take that idea of production line manufacture and measured quality to a limit. Prior recommendations have taken a gander at reactors in the scope of 100 to 300 megawatts of electric yield, which are a factor of 10 more modest than the customary huge monsters, the enormous atomic reactors at the gigawatt scale. These could be amassed from manufacturing plant constructed segments, yet they actually require some gathering at the site and a great deal of site planning work. In this way, it's an improvement over the conventional plants, however it's anything but a colossal improvement. This atomic battery idea is actually something alternate due to the actual size of these machines, around 10 megawatts. It's little to the point that the entire force plant is really implicit a manufacturing plant and fits inside a standard holder. The thought is to fit the entire force plant, which involves a micro-reactor and a turbine that changes the warmth over to power, into the compartment. This gives a few advantages from a monetary perspective. You are totally decoupling your activities and your innovation from the building site, which has been the wellspring of each conceivable timetable deferral and cost overwhelm for atomic undertakings in the course of recent years. This way it becomes kind of energy on request. In the event that the client needs either warmth or power, they can get its anything several months, or even weeks, and afterward it's fitting and play. This machine shows up on the site, and only a couple days after the fact, you begin getting your energy. Along these lines, it's an item, it's anything but an undertaking. That is the manner by which I like to portray it. Q. You talk about conceivably having such units broadly disseminated, incorporating even in local locations to control entire areas. How certain can individuals be regarding the well-being of these plants? It's outstandingly strong, that is one of the selling focuses. Most importantly, the way that it's little is useful for an assortment of reasons. For a certain something, the general measure of warmth that is produced is corresponding to the force, which is little. Be that as it may, all the more significantly, it's anything but a high surface-to-volume proportion on the grounds that, once more, it's little, which makes it much simpler to hold cool under all conditions. It's inactively cooled, to a point where no one needs to do anything. You don't have to open a valve or anything. The framework deals with itself. It's anything but a hardy regulation construction encompassing it to ensure against any arrival of radiation. Rather than the conventional large substantial vault, there are steel shells that essentially typify the entire framework. What's more, concerning security, at most destinations, we imagine that these would be situated underneath grade. That gives some insurance and actual security from outside aggressors. Concerning other well-being issues, in the event that you consider the celebrated atomic mishaps, 3 Mile Island, Chernobyl, Fukushima, Every one of the three of these issues are intervened by the plan of these atomic batteries. Since they are so little, it's fundamentally difficult to get that sort of result from any grouping of occasions. Q. How would we realize that these new sorts of reactors will work, and what might have to occur for such units to turn out to be generally accessible? NASA and Los Alamos National Laboratory have done a comparable exhibition project, which they called a microreactor, for space applications. It took them only a long time from the beginning of plan to creation and testing. What's more, it cost them $20 million. It was significant degrees less than customary enormous atomic plants that handily cost $1 billion or more and require 10 years or more to assemble. There are additionally various organizations out there now fostering their own plans, and each one is somewhat extraordinary. Westinghouse is as of now chipping away at a rendition of such atomic batteries. However, they are not utilizing that term, and they intend to run a show unit in 2 years. The subsequent stage will be to construct a pilot plant at one of the public labs that has broad gear for testing atomic reactor frameworks, like the Idaho National Laboratory. They have various offices that are being adjusted to oblige these microreactors, and they have additional layers of well-being. Since it's an exhibit project, you need to ensure that if something happens you didn't anticipate, that you don't have any delivery to the climate. Then, at that point, the plant could go through a sped-up program of testing, exposing it to more outrageous conditions than could at any point be experienced in typical activity. You basically misuse it and show by direct testing that it can take that load of outer burdens or circumstances without surpassing any disappointment limits. Furthermore, whenever it's demonstrated they're under thorough conditions, broad business establishments could start rapidly. These atomic batteries are unmistakably fit to make flexibility in altogether different areas of the economy, by giving a consistent trustworthy wellspring of ability to back up the expanding dependence on irregular sustainable power sources, for example, sun-oriented and wind. What's more, these profoundly circulated frameworks can likewise assist with lightening pressures on the network by being sited exactly where their yield is required. This can give more noteworthy flexibility against any disturbances to the matrix and basically take out the issue of transmission misfortunes. In the event that these become as broad as we imagine, they could make a critical commitment to decreasing the world's ozone-harming substance outflows.